This diagram is very important and you have to write this diagram in the examination when they ask for the proof. Let us cross multiply this. If you cross multiply, you are going to cross multiply m here and then this will be cross multiplied to the right hand side. R vector is equal to mb vector minus na vector divided by m minus n. That's it. So this is what the formula when it divides in the ratio externally m is to n. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on collinearity of vectors and also how to prove the right angle triangle in a vector. Now in today's session, dear students, here we are having session number 3 and then here we are going to have problems of 3 marker. Here they are going to give more problems of 3 marker only in your final examination. I have taken what are the types of problems you are going to get under 3 marker. Now here we will be moving on to the first problem. This is very important, dear students, as well as this is called as the theorem. They can ask you to prove like this. Show that the position vectors of the point P which divides the line joining the points A and B having the vectors as A vector and B vector as a position vector internally in the ratio m is to n, or prove that R vector is equal to mb vector plus na vector divided by m plus n. Dear students, this diagram is very important and you have to write this diagram in the examination when they ask for the proof. Now here I have taken the position vector is nothing but OA vector, which is nothing but A vector, and OB of position vector B vector is nothing but B, and then OP is nothing but here. And then after taking the position vector, I have joined the points, these 2 points, and called that vectors as A and B. That's it. And here taking the point P has OP vector is a position vector which will be is equals to R vector. Now here let me take it as whatever the given, and initially I am going to take the proof like this. This sentence is very important, so that I have taken let A and B be the 2 given points with the position vector. OA vector is equals to A vector, OB vector is equals to B vector, and let P be the any point AB divides internally in the ratio m is to n. This is very important. And then from the diagram you know that, see there, PB divided by PA will be is equals to n by m. That's what I have taken. PB vector divided by AP vector is nothing but n by m. So therefore, according to what we have defined here, PB vector can be written as what? PB vector is nothing but OB vector minus OP vector, correct? Divided by AP vector can be written as OP vector minus OA vector is equals to n divided by m. And then dears, let us cross multiply this. If you cross multiply, you are going to cross multiply m here and then this will be cross multiplied to the right hand side. So you are getting m into, correct? So OB vector as it is I am writing minus OP vector is equals to n into OP vector minus OA vector. Now here you know already what is OP vector is given by DS. OP vector is nothing but R vector. So therefore you can write it here by substituting m into OB vector is nothing but what? B vector minus OP vector is nothing but R vector is equals to n into OP vector is again R vector minus OA vector is nothing but A vector. So we are going to write because OP vector is equals to R vector, substituting, correct? Now here you can multiply m into B vector minus m into R vector is equals to n into R vector minus n into A vector. Now collect the negative. This negative, if it comes to this side, it will become positive. So therefore mb vector plus na vector is equals to nr vector plus mr vector. How? I'm taking this m r to that side, it will become positive because you are having here negative. So therefore, you can have common factor here r vector. So mb vector plus na vector is equals to, taking r vector as common here, r vector remaining is anyway 1 plus 2 is equals to 2 plus 1. So m plus n or n plus m. Here I am writing n plus m. So therefore, you can write it as r vector is equals to, cross multiply m plus n. So mb vector plus na vector divided by m plus n. That's it. This is what the proof you are going to get it as DS. Understood? Now, same thing you can have for the externally. Externally formula is given by, this is internally. If they ask externally in the ratio m is to n, externally in the ratio m is to n, then the formula you are getting DS, just simple, r vector is equal to mb vector minus na vector divided by m minus n. That's it. So this is what the formula when it divides in the ratio externally m is to n. So I hope you understood this proof, how to prove, right? Now we'll be moving on to the next problem, what they have asked. Find the position vector of the point R which divides the line joining P and Q internally and externally in the ratio 2:1. And given it as A vector is I plus 2j minus k and B vector is minus I plus j plus k cap. Now here, let me take whatever the given ratio. Ratio they have given it as what? Given m is to n. M is to n is equals to 2:1. Therefore, m will be is equals to 2, n will be is equals to 1. You know already r vector. So this is for the first one. First one means which is the internal division. So r vector is given by mb vector plus na vector divided by m plus n. Now m and n they have given it as a ratio 2:1 and a vector, let me substitute. So m is nothing but 2 into b vector. B vector is here minus I plus j cap plus k cap plus 1 because n is equals to 1. 1 into a vector, this one. So I cap plus 2j cap minus k cap, correct, divided by m plus n, which is 2 plus 1. So here you can have, which will be implies that, see, 2 into minus I, which is minus 2i. So minus 2i, again 2 into plus j is plus 2j. Again 2 into plus k is 2k. Again you can multiply plus 1 inside. Same vector you are going to get I plus 2j. I plus 2j minus k cap, correct, divided by 2 plus 1 is nothing but 3. So which implies that, correct, or which is equals to, that is r vector. So minus 2i plus I, which will be giving you minus I plus 2j which is 4j. Again plus 2k minus k, which is plus k, divided by 3. And this is your r vector. You are going to get it when it is having internal division. That's it. If you want, you can segregate minus I by 3, 4 by 3, j plus k by 3. That is 1 by 3 into k cap. Okay. Now we'll be moving on to the second one, external division. So external division is given by the formula. What it is? R vector will be is equals to, as I told just now, mb vector minus na vector divided by m minus n. M is nothing but 2 into b vector is nothing but minus I plus j plus k minus 1 into a vector is I plus 2j minus k divided by, be careful here, 2 minus 1. Now which will be multiply minus 2i, correct, k cap, j cap, now plus 2j cap plus 2k cap, here minus I cap Plus into minus is minus 2j cap. Now minus into minus is plus k cap. Divided by 2 minus 1 is nothing but 1. So no need to write in the denominator. Correct? Divided by 1 means the same thing as the numerator. Now which will be implies that minus 2i minus I, which is minus 3i cap, plus 2j minus 2j will get cancelled. Now 2k cap plus k cap is nothing but plus 3k cap. Now this is your final answer you are getting when you are going to have external division of 2:1. That's it. Now we'll be moving on to the next problem. Find the position vector of the point R which divides the line joining P and Q internally and externally in the ratio 1:2. In the last problem it was 2:1. Here they have asked 1:2. So M is equals to 1 and N is equals to 2. Now here where A vector they have given it as 2i cap minus j cap plus 2k cap, and B vector they have given it as minus I plus j minus k cap. Now let us do first internally. First write down what is the ratio they have given. M is to N they have given it as 1:2. So be careful, M is equals to 1 and N is equals to 2 here. So let me take first the internal division. So which is given by R vector is equals to MB vector. Dear students, writing this formula in the examination very important when they asked internal division and then external division. Now which implies that M takes the value here 1, B vector is nothing but minus I plus J minus K. Again plus N takes the value 2 into 2i cap minus j plus 2k divided by, you are having M is equals to 1, N is equals to 2. Now let me multiply that. So 1 into anything will be the same thing. So minus I plus j minus k, again 2 2s are 4i. So plus 4i, again 2j minus into plus is minus 2j, again 2 into 2 plus 4k cap. So divided by, here 1 plus 2 gives you what? 3. So 3. Now simplifying the numerator, minus I plus 4i gives you what? Plus 3i. Again plus j minus 2j, which is minus j. Minus k plus 4k is plus 3k divided by 3. If you want, you can divide that one. 3 by 3 gives you I minus 1 by 3 into j, 3 by 3 plus k. Okay, and this is your final answer. You are going to get it as. I hope you got this. Now the same you are going to do the external division, which is the second one. Let me do. So that is R vector, it is given by MB vector minus NA vector divided by M minus N. Now let me write M is nothing but 1 into B vector is minus I plus J minus K, again minus N is nothing but 2 into A vector is nothing but 2i minus j, again plus 2k. Correct? Divided by, you are having 1 minus 2. So which implies that minus I plus j minus k, again minus 2 into 2 is minus 4i, minus 2 into minus j is plus 2j, minus 2 into plus 2 is minus 4k, right? Divided by 1 minus 2 is nothing but minus 1. Now which implies that minus I minus 4i is nothing but minus 5i, again plus j plus 2j is nothing but plus 3j, minus k minus 4k is minus 5k divided by minus 1. If you divide by minus 1 or multiply throughout by minus 1, you are getting negative by negative, it will become positive 5i, again positive by negative, it will become negative 3j, negative by negative, it will become positive 5k. That's it. And this is your final answer for the external division of the given A vector and the B vector. I hope you understood this problem. Now we'll be moving on to the next one. Show that the points A of minus 2i plus 3j plus 5k, B of I plus 2j plus 3k and C of 7i minus k are collinear. Dear students, when they have given two vectors, you are going to prove by taking B vector will be is equals to lambda into A vector. This is when the two points are given or two vectors are given. Now here they have given a 3 points A, B and then C. So how to prove that? You are going to prove sum of the two vectors will be is equals to the other vector. So here let me take it as which is given by A of minus 2i plus 3j plus 5k as nothing but OA vector. So position vectors of A, B and C is given by is OA vector is nothing but minus 2i plus 3j plus 5k. So position vectors of A, B, C are OA vector is equal to minus 2i plus 3j plus 5k. Again OB vector is equals to I plus 2j plus 3k. Similarly, OC vector is given by 7i minus k. Right? So here let me find out what is AB. So AB vector is given by OB vector minus OA vector. Now OB vector here only let us minus. OB vector is this one, I minus of minus 2i which is plus 2i, I plus 2i is 3i. Similarly 2j minus 3j, 2j minus 3j is minus j, right? Similarly 3k minus 5k is nothing but you are getting minus 2k. Now this is your AB vector. Now let us do like that only BC vector. BC vector is given by OC vector minus OB vector. Now let us do what is OC vector here. 7i minus I is nothing but 6i. So BC vector is 6i. You do not have here minus of C, you are doing minus of 2j which will become 0j minus 2j is minus 2j, correct? Because you do not have here what is that, a j term only. So you are going to take it as 0 into j, minus 2j is minus 2j only, minus k minus 3k is minus 4k. So this is what your BC vector. Now let us find out what is AC vector or CA vector. So which is given by OC minus OA, correct? So OC minus OA is nothing but 7i minus of minus 2i which is plus 2i. 7i plus 2i is 9i cap. Now again here you do not have j term, 0j minus 3j which is nothing but minus 3j only, correct? Now again you are having minus k minus 5k which is minus 6k. Now you have found out all this one. Now let me find out magnitude of all this. Now let me take it as AB vector which is magnitude of AB vector is given by what is that? Square root of coefficient of I is 3 squared. Again coefficient of j is 1 square which is minus 1 square. Coefficient of k is minus 2 whole squared, correct? Similarly, you are going to have evaluating this 3 squared is nothing but 9, 1 squared is nothing but 1, 9 plus 1 is 10, again minus 2 whole squared is 4, 10 plus 4 is nothing but 14. So you are getting under the root 14. This is your magnitude of AB. Similarly, let us find out magnitude of BC. So which is given by under the square root of C here. So 6 squared minus 2 whole squared minus 4 whole squared. Let us do that. Square root of 6 squared plus minus 2 whole squared plus minus 4 whole squared. Now you are going to get it as 6 squared is nothing but 36. Again 2 squared is nothing but 4. 36 plus 4 is 40. Again 4 squared is nothing but 16. 40 plus 16 is under the root 56. Now under the root 56 can be written as which will be is equals to you are getting root 4 into 14. See, 4 4s are 16, 6, 4 1s are 4, 4 plus 1 5, 56. So therefore under the root 4 can be written as 2 root 14. So this is your magnitude of BC vector. Let us find out magnitude of AC vector. So magnitude of AC vector is given by, see, 9 squared plus minus 3 whole squared plus again minus 6 whole squared, right? So which implies that 9 squared is 81, 3 squared is nothing but what? You are going to get it as 9. 81 plus 9 is 90, 6 squared is 36. So 90 plus 36 is nothing but 126. So under the root 126 can be written as under the root of 9 into 14, which is 14 nines are 126. So 3 root 14, correct? Because under the root 9 is 3. So root 14 as it is you are writing, which if you are adding you are going to get another number. 2 root 14 plus root 14 is 3 root 14. Therefore, you can have magnitude of AB vector plus magnitude of BC vector is equals to magnitude of AC vector. That is, magnitude of AB vector is root 14, BC vector is 2 root 14, CA vector or AC vector is 3 root 14. That is, 3 root 14 is equals to 3 root 14, correct? And this is your collinearity condition. Either they are going to give 3 points and then you are going to prove like that. Otherwise, they are going to give 2 points, then you are going to prove like this. B vector is equals to lambda into A vector, where lambda is nothing but the constant. Okay. We'll move on to the next problem. What they have asked, show that the points A, B and C with the position vector, A vector is 3i minus 4j minus 4k and B vector is equal to 2i minus j plus k and C vector is equal to I minus 3j plus minus 5k respectively form vertices of right angle triangle. So in the last session we have proved this type of problem. Let me prove it here also. So here they have given the position vector, which is I can have A vector, position vector given can be OA vector is equals to 3i minus 4j minus 4k. Similarly, a B vector which is given by OB vector is equals to 2i, this one, minus j plus k. Similarly, C vector, position vector is OC vector given by I minus 3j minus 5k, right? Now here, let me find out first what is AB vector. What is AB vector? Because we need to prove that hypotenuse squared modulus of is equal to opposite squared plus adjacent squared. So we need to take the magnitude of AB, AC and then BC, and then whichever the hypotenuse and adjacent and opposite we need to decide accordingly. Now here AB vector can be given by OB vector minus OA vector. Now let us minus OB and then OA. OB vector is this 2i minus 3i, which is minus I, right? Again minus j plus 4j, because minus of minus you are going to minus that. So minus j plus 4j is plus 3j, again plus k minus of minus 4k, which is 4k, so plus 5k, right? And then similarly, let me find out this magnitude. What is this magnitude is given by? So magnitude of AB vector is given by under the root of minus 1 whole squared plus 3 squared plus 5 squared. So which is given by minus 1 whole squared is 1, 3 squared is nothing but 9, 9 plus 1 is nothing but 10, 5 squared is 25. So 10 plus 25 is under the root 35, correct? Right? Similarly, let me find out BC. BC vector is given by OC minus OB. Now, let us take OC vector here. I minus 2I, which is minus I. Again, minus 3j plus j, which is minus 2j. Again, you are having minus 5k minus k, which is minus 6k. Let us find out this magnitude also, which is given by under the root minus 1 whole squared plus minus 2 whole squared plus minus 6 whole squared, because coefficient of I is minus 1, coefficient of j is minus 2, coefficient of k is minus 6. Now which is given by minus 1 whole squared is plus 1, minus 2 whole squared is what you are having 4, 4 plus 1 is 5, again minus 6 whole squared is 36, 36 plus 5 gives you 41. So therefore under the root 41. Let us do similarly AC. So AC is given by AC vector is nothing but OC vector minus OA vector. Let us do that. What is OC vector? This one. I minus 3I, which is minus 2I. Again, minus 3j minus 4j, which is plus 4j minus 3j is plus j. Again, minus 5k plus 4k is nothing but minus k. Now, magnitude of AC is given by under the root minus 2 whole squared plus 1 squared plus minus 1 whole squared. So, which is given by minus 2 whole squared is 4 plus 1 squared is 1, 4 plus 1 5, again minus 1 squared is 1, 5 plus 1 6. So, under the root 6, this is magnitude of AC vector. Now, let us do here which is adding gives you the another. So, here you can have 35 plus 6 gives you 41. So, therefore, I can have magnitude of AB vector square will be is equals to 35 plus 6 gives you 41. So, 41 can be written as 35 plus 6. So, therefore, magnitude of BC vector square gives you magnitude of AB vector square plus magnitude of AC vector square, correct? So, which will be, magnitude of BC vector is under the root 41 square can be written as under the root AB is nothing but 35. So, 35 whole square plus under the root 6 whole square. So, 41 will be is equal to 35 plus 6, otherwise 41 is equal to 41. This is proving the given points A, B, C are said to be right angled triangle. I hope you understood this session how to prove some more problems of a 3-marker, and very important theorem you have studied, which is internal division, as well as you came to know the formula of external division. Based on that, you have solved the problems. So, in the next session, we'll be moving on to the next concept of the vector algebra. Until then, dear students, keep watching. Thank you. Have a nice day.